So now that you know what the limitations of Java futures are, let's discuss how Java completable futures overcome these limitations. Now, I've given you a short overview of Java completable futures much earlier, last week in fact, and so you have a little inkling of what completable futures are about, but it really won't become clear until we go into more detail about completable futures, how they overcome all these limitations in the most grand way. We'll just give you a taste of how they overcome them. So we'll see that completable futures are designed to slay the dragon of complexity that arises with Java futures. In particular, one thing you can do with a completable future is you can explicitly complete it. That was one thing you could not do with traditional Java classic futures, we'll call them. So we could complete them, much like a donut hole completes a donut. So you can see here, and we'll take a look at this example later, you can see here how you can create an empty future, actually an empty completable future, and then we can spawn a thread which does a bunch of computations, and it provides a result and completes that future explicitly. And then the calling thread can get the result after it's been completed. So that's one thing it's very easy to do with newer completable futures. You can complete them, whereas it's very hard, very complicated to do that with traditional Java futures. Something else you can do, which is really one of the most important things, is you can chain together actions that handle the results of asynchronous computations efficiently and cleanly. And the way this works is using something called a completion stage method, and we'll talk a lot about those because that's the bulk of the methods in Java completable futures are completion stage methods. And they get triggered when the previous stage's completable future completes. By the way, when I use future here, I'm just using it as a shorthand for completable future to not have to keep saying this over and over again. And this gives you a nice fluent interface style model. So as a result, asynchronous programming looks a lot like synchronous programming, which is really cool, except these things are now running asynchronously in the background. So for example, in this particular snippet of code, we say, start reducing a fraction in the background by calling the supply async factor method. And then we say, after that's done, then convert the result of that reduced fraction into a mixed string, which is a mixed fraction or a proper fraction. And then go ahead and take the results of doing that and print it to the output. And all of these calls are likely to take place in a background thread as opposed to the main thread. But it looks synchronous in the way that you programmed it. So it looks like you're just flowing the chain of calls together in a nice fluent model. Another nice thing you can do, very, very powerful, very cool, is you can have one completable future triggered efficiently when a collection of completable futures finish, without a lot of extra programming complexity, without a lot of extra overhead. So these are triggers, just like you trigger an avalanche. So we'll take a look at this example later as well. This example is kind of fun. It creates a stream of completable futures up to some number, like 100. And then it goes ahead and it multiplies or reduces and multiplies them in the background. So we've got, let's say, 100 multiplications and reductions taking place in the background on randomly generated big fractions. And then we're going to collect the results together into a single completable future. And that single completable future will then trigger only when all the other asynchronous computations are finished. And after that happens, then we go ahead and print the results. And I could have written this a little bit better. I probably should eat my own dog food and not write this with a local variable, but to stream the whole thing together. But the bottom line is that we can have a single completable future that's triggered when all the other completable futures are done. This example also demonstrates something very important, which is cool, is how you can combine Java completable futures together with Java sequential streams. So Java sequential streams gives us a way of being able to structure the overall flow of computation in this program, and then we can use completable futures to have the computations that are running in that flow be running asynchronously. And that's a really nice combination of things. In fact, it's such a nice combination of things that later versions of Java actually institutionalized that combination with something called reactive streams, which kind of gives you the best of streams and the best of completable futures in a somewhat more integrated syntactic and semantic framework. So I typically think of this as like peanut butter and chocolate. So I'm a big fan of peanut butter and chocolate. They taste good separately, but they're even better when you put them together. So when we combine completable futures with sequential streams, we get something that's even more tasty. So that's the quick overview of how completable futures overcome those earlier limitations with Java futures we talked about. Now we're going to get a chance to start delving into the complexities and the wonderful, powerful aspects of the Completable Future Framework API.